Hello again. This is part 2 of 8.2 permutations. Example number 8 here. Out of the 12 songs on your all-time favorite list, how many ways can you listen to 4 of them? So to listen to 4 of them, that you're choosing 4 or arranging 4 objects out of 12 objects, where order matters here. So 12 permutation 4, 12p4. You're choosing 4 out of 12, and you care about the order because listening to the songs will happen in order, right? If it asks you how many ways can you choose 4 out of 12 here, I would not count that as permutation because listening is happening in order, but choosing is 4 out of 12 anyways. It's the same group. It doesn't matter how I arrange them, but it's going to count as one group. So listen here indicates or implies to um, order matters. So 12p4, and you use the calculator for that to get the answer here. So I get my calculator and type in 12 P4, so second function here, I see NPR over the sixth pattern, and most calculators that would be the case. So 12 depends on what kind of calculator you have. So the answer for that would be 11880. That's the number of ways. For example, number 9, that's pure algebra there. We are not given sample of objects to arrange or anything, but we are required to use the expansion of permutations. And for this one here, I'm going to start on the left-hand side. This is the side that will take some expansion here. And this would be n factorial on the top. At the bottom, it would be n minus 2, the difference factorial, and that's equal to 56. To get that done, I need to expand the factor on the top. So n factorial counts as n multiplied by n minus 1. You're going down by 1 each time, each factor, and multiplied by n minus 2. Once you hit the factor at the bottom, you stop there and make that factorial instead. So n minus 2 factorial again equals 56. And if you take a closer look, these are the same factors, n minus 2 factorial, the whole thing together. You're not leaving the factorial sign behind. And that will give you n squared when you distribute the n over the bracket here. You have n squared minus n equals 56. That is a quadratic equation. So to solve it, I need to bring everything to one side, make it equal to 0, and try to factor. So what I have here is n squared minus n minus 56 equals 0. Now we try to factor this. We have to find two numbers that when you multiply, you get negative 56, and when you add, you get negative 1. So basically, the difference in the absolute value would be 1. I would say we have negative 8 and positive 7 here. And since the product of these two factors equals 0, then any of them could be a 0. So n minus 8 equals 0, n plus 7 equal 0. And when you isolate n, you get n equals 8, or n equals negative 7. Actually, the value of n equals negative 7 is rejected. N has to be greater than or equal to 2 based on the given here. Or basically, n cannot be negative under any condition or even 0. So n here has to be greater than or equal to 2. Greater than or equal to 2. Because I'm choosing 2 objects out of n. N is impossible to be less than 2. So n equals negative 7 is rejected, and I have to show that in my answer. The only answer that's valid here is n equals 8. Okay, so this is this kind of question where you have to use the expansion to get the value of an unknown variable. Now, with the second example here, it could be a little bit confusing. So please pay attention. Please pay close attention to what we're going to do here. So this 5 is going to be 5 factorial at the top. And at the bottom, I have 5 minus r factorial, and that's equal to 20. I don't have r on the top to be canceled with any factor from the bottom, so I'm avoiding that idea now. And I find the value of 5 factorial. 5 factorial is 5 times 4 times 3 times 2, which is 120 at the end. This would be 5 minus r factorial, and that's equal to 20. At this point, I can do some simplifying, or I can choose to do cross multiplication right away. So if I multiply these two, multiply, multiply, so I have 20 multiplied by 5 minus r equals 1 times 20, which is 120. Now we might want to divide this by 20, it's 1. Divide the other side by 20, it is 6. I have, oh, I missed the factor notation here. Right now, I have only 5 minus r factorial equals 6. How do you find the value of r here? What could be a possible value for r? The only way we do that is to change the other side into a factorial notation and equate the inside of the factorials. So right here I have 5 minus r, and instead of 6, I know that 6 is 3 times 2 times 1, which is the same as 3 factorial. So I can easily think about that on the side here and replace 6 by 3 factorial. What does that mean for me? It means that the inside of the factorials would be equal. So this is the same as 3. So untangle the situation, remove the factorials now. So 5 minus r equals 3. Then isolate r. I have negative r here equals 3 minus 5. And that leads to negative r equals negative 2. Now you cancel the negatives. You have r equals 2, and that is the answer for this question. Okay, for practice for 8.2, I encourage you to answer questions from the textbook again. Let's use the textbook. Textbook questions. Uh, 3 to 10, starting on page 701. Okay. Good luck, everyone, and see you in the next video for 8.3, the third lesson of this unit. Thanks a lot.